Very good evening, everyone. Myself, Anmol Chauhan, and I am a computer science engineering student from Charuset University. First of all, I would like to thank Dr. Praveen Sukumaran and Dr. Parth Chauhan for giving me an opportunity to present over here. So, beginning with the topic, Introduction to Google Earth Engine. So, basically, the Google Earth Engine is used for analyzing vast geospatial data to monitor Earth changes using two things: cloud computing and satellite images. When we go towards the flow of today's lecture, it is divided into 5 categories. First one is some basics of the Google Earth Engine. Second is the exact difference between geographic information system, the Google Earth, and the Google Earth Engine. And how does Google Earth Engine benefit over the GIS? Third will be certain applications and working of the Google Earth Engine, where we will also be looking into some samples. Fourth will be time-lapse creation for certain historic sites of India through Google Earth Engine. Fifth will be demo, or we can even say it will be a hands-on we will be taking few artifact sites of India. We will be analyzing its past 40 years of data through Google Earth Engine through two modes. First mode will be directly through its website, but through its website we won't be able to get the vegetation index and water index time lapse. So we will also enter into some basic coding stuff to see how the time lapse works. The Google Earth Engine has over 50 petabytes of satellite data of global environment. Generally what happens is everything is on the cloud. So whatever processing you do, it will be on the cloud. You don't even need to download those large data sets. It has over 40 plus years of Earth observation data. Over 100 plus countries relies on Earth Engine for data-driven decisions, and it combines cloud computing with 5 million satellite images. These are some of the widely used publicly available data sets which are available on the Google Earth Engine. First is the Landsat and Sentinel data, where we have imageries of raw, the top of atmosphere, Sentinel reflectance. Then we have MODIS data sets, we have terrain, we have land cover, we have atmospheric, and there are a lot more publicly available data sets, and they are updated on daily basis. Means the process works on a real time. Means there is a thing which we call as a satellite API, which is directly linked with the Google Earth. Every second, whenever a new image is generated, it is directly uploaded on the Google Earth Engine cloud. Approx more than 4,000 new images of satellite imagery are added over it. This is a sample time lapse of a region which is officially provided by the Google Earth Engine. Here you can notice on the above left corner, the data flows from 1985 to 2015 at 15 frames per second, where you can notice the change in behavior of the river, the change in behavior of the vegetation, how a village grows into a huge city and everything. And this whole process is completed under 20 seconds. If you use a GIS, it will take a lot more time to see these results, but if you use the Google Earth Engine, it takes less than 20 seconds. Now we will be talking about some difference in the geographic information system, the Google Earth, and the Google Earth Engine. First, I would like to make a clear difference of that Google Earth and Google Earth Engine both are completely different. Google Earth is just a virtual globe for visualization, whereas in Google Earth Engine you combine cloud computing and satellite imagery for analyzing the data. Here in this slide, you will be able to find out that in the first image we can see the manual process, how this time-lapse things works using the GIS. In GIS, you require some high-end workstations. You need to download large data sets. You require special license softwares. You need to pay a very high amount. Plus, it also takes a lot more time to analyze a time lapse of 40 years of data. Sometimes it even takes months to analyze. Whereas in Google Earth Engine, it saves your time. The whole process is driven in the cloud. It is cost effective for a student or a researcher. If you are using for non-commercial uses, then Google Earth Engine is completely free of cost. And also it's cloud based. So it is very efficient in data processing. Here in this slide, I would like to tell you how this thing actually works. Means how do you get the results in just 20 seconds? Here what happens is, I have explained it in a very simple language, that if you select a region in a Google Earth Engine, it is divided into small independent grids, and it is distributed in various CPUs of the Google Cloud, and each grid performs its operation independently. And whenever all the grids have completed their process, they merge and then they give you the output. Basically, it is also known as parallel processing, where each grid processes parallelly with the other grid. And it is also very efficient because the time is reduced by a very high rate. So now we will see the applications of the Google Earth Engine. So mostly it is used in climate studies. It is used in analyzing climate change, temperature anomalies, and sea level changes. It is used in environmental monitoring for tracking deforestation, erosion, biodiversity. It is also used in resource management for accessing water resources, soil moisture, carbon stocks, for urban development. As we have seen in the past slide, we saw like how the city was emerged, how the urban development was going on. So it was an example of this Google Earth Engine. The fifth is historical preservation. We will be seeing certain examples of this fifth part ahead in our slides, that how we have used Google Earth Engine for preserving historic and archaeological sites in India. This is just a quick overview of which data sets are available on the Google Earth Engine. Here you can see Landsat, here you can see GPM, and currently in our program we have used the Landsat 9 image collection for more accurate and precision of the answers of the results. Okay, so this is basically how the Earth Engine code editor looks like. It's actually very simple. Like if you feel like there is too much of code to write, there are many things already provided where you just need to change certain values. Like if you open, like we will also have a demo on how this thing actually works. When we open the Google Earth Engine code editor, in the bottom part, we will be able to see the map. We can select various maps. We can select the road map. We can select the satellite map. We can select the terrain map. Then on the left hand side, we can see the drawing tools through which we can mark any region we want for the time lapse or for any kind of analysis. We can even insert our own data if we have some own files or something that we can insert over here. Then there is a search bar of one particular region. You can write a code over here, like you want to time lapse from which date to which date, which filters you want to apply, and many more. And then when we hit the output button, we will be able to see the result over here on the map itself. Okay, so this is a sample of NDVI that we performed on the Google Earth Engine code editor. Here you can see that a small rectangle was drawn over a region using the drawing tools on the bottom left hand side, and we named it as geometry. So when you look into the code structure, we have called the image collection of Copernicus. We have even put a filter date of 1st October to 30th November. And in the third line, you can see filter bounds of geometry, means whatever filter we apply will be on that particular geometry only. Then there is a line which we define as NDPI, Normalized Difference in Vegetation Index. where we will be able to see different levels of vegetation index directly from the Google Earth. We just need to apply the formula of near infrared minus RED and near infrared plus RED. Using this property, we will be able to see the normalized difference in vegetation index of a particular region. Okay, so in the examples that we tested on the historic sites for finding the normalized difference in vegetation index, normalized difference in water index, normalized difference in soil index, and modern normalized difference in water index, we use these 20 artifact sites that includes Jwalapuram, Atirampakam, Netankheri, Hathnora, Isampur, Bhimbetka, Bamburivan, Mehtakheri, Kathoti, Adamgarh, Patne, that we'll be seeing further in our slides. This is the entire flow of how we perform the operations. Like, we first imported the Google Earth Engine map in our Jupyter Notebook. Jupyter Notebook is basically a coding compiler where you write codes. Then we mark the artifact site area that we want to see the time lapse of. Then here the third part I have written is compare site location from WebGIS module. The 20 artifact site data that we used in Google Earth Engine, we actually found those data in a road database where those artifact sites were originally published. Then we compared the time lapse in Google Earth Engine. Then we selected the color combination, like we want RGB or some other color combination. Then we selected the normalized difference index of NDVI, NDWI or NDSI. Then we select the frames per second, like in how many seconds you want to see how many years or months of time lapse. Then we mention the start date and the end date. Then we apply the F-mask property. Basically, how this F-mask property works is when you put an artifact site in the Google Earth Engine, you will be able to see many cloud layers or snow layers on the above. Like, to remove those cloud layers, we need to apply the F-mask property so that we can clearly see the region that we want to see the time lapse of. And then we hit the time lapse button and we get the entire time lapse of past 40 years. This part is of my coding output Jupyter book. When we reach at the end, like as I showed you previously, here we will be able to select a RGB combo. Okay, is my cursor visible, sir?
Yes, Anmol.
Okay, so here we will be able to select the RGB combo. Here we will be able to select the frames per second. Here we will be able to apply the F-mask property to remove clouds, shadows, snow. We will be able to select the start year, end year, start month, end month, and so on. Then here we will be able to select the normalized difference index. Here you can see there are 3 indexes. And then we will hit the create time lapse button. So as an example, firstly we took these 4 sites, that is Bhimbetka, Adamgarh, Netankheri and Hathnora. These 4 artifact sites are published in the road database, and for the time-lapse creation of these sites, we picked up these sites. And these were the results that we got for the normalized difference in vegetation index. And I have posted some results over here where I can see a clear difference from 1993 to 2024. First images of 1993, then 1998, then 2000, 2003, 2017, 2021, 2022, and the latest 2024. The 2024 data was available because we used the Landsat 9 image collection in our coding structure. Here is a clear visual representation of how actually the time lapse looked when I applied 2 frames per second. On the left hand side, we can see just a normal time lapse. It doesn't have any indices on it. Like it doesn't include any vegetation index nor the water index. And on the right hand side, we can see modern normalized difference in water index. And we can see this very beautiful results through the Google Earth Engine only. So here we will be able to see data from 1993 up to 2020 in the time lapse. This is one more example of artifact site which we call Hathnora and Nitalkeri. We plotted these 2 points on the Google Earth Engine, and we can see a very clear representation of how normalized difference in vegetation index works with the Google Earth Engine from 1993 to 2022. Like we will be able to see a clear difference of how the vegetation actually grew in the years. And here we have also kept certain filters of months, like we selected only one particular month to see the time lapse. Like if we selected October, then the images will be from the month of October only for the following years. Now, before coming to the challenges phase and conclusion, we will be going towards the demo and how Google Earth Engine actually works. Okay, so this is how the Google Earth Engine website looks like. Firstly, we will be going towards the data sets. There are many publicly available data sets which we can use for practicing or analyzing any of this stuff. Okay, yeah. So these are the data sets, and also here we will be able to see like what work other people have carried out on these data sets. Like here we have Canada annual crop inventory. We have some other Netherlands data where we can analyze some bacterial information like spreading of bacteria, spreading of different light waves. We can even analyze the nightlife of a city on how did it evolve. We can even analyze the various physical heights of an island or anything else through all these data sets. These are some of the list of data sets which you can surf. Then when we open the Google Earth Engine code editor, like from here we get started and we open the Google Earth Engine code editor, and it looks like this. Yeah. So basically for sample purpose, I use this Australian site data image collection, where you can see in this region of the Google Earth Engine, I plotted a map. I then gave the tag as geometry. Then I selected the data set as elevation. These are the elevation minimum meters point and maximum meters is 150 meters in this elevation. Then we set the map center, and then we add this elevation layer onto the map to see how it exactly looks like from the sea level up to the maximum height. So this is how we write a code over here to see the output. Apart from it, there is also one more thing which we can see the time lapse of without writing the code in the Google Earth Engine. There is a button over here which we call time lapse. Okay, here also we will be able to see the time lapse which Google Earth Engine directly provides. Like if I play this button, you will be able to see how things evolve over year from 1984 to 2022 for any particular region. Yeah, but the only drawback over here is we won't be able to apply any filters or any layers on it. Like we will only be able to see the basic time lapse. We won't be able to include the vegetation index layer or water index layer or the sea level, height level index layers or anything. Like we can't do anything over here. For that, we need to write the code either in the Google Earth Engine code editor or on any other coding platforms. So now we will be going towards a demo on how we get the time lapse of a particular area under 20 seconds. So this is my coding platform book, which we call as Jupyter Notebook, and I will try to explain in a very basic manner. Like I will make sure that you at least understand how the flow actually works, like how things flow in a manner from the beginning up to getting the time lapse. I won't go much in detail of how code is written. So here we import GEE map, means Google Earth Engine map. After importing the Google Earth Engine map, in this box we will be able to make sure which map to select. Here instead of hybrid, I can write road map, I can mention satellite map, I can mention ARIS map or any other map I want to choose. I can even write Google Maps over here. So we will get an interface exactly as the Google Maps. After getting the map over here, we will plot an artifact site on Nathan Carey. Yeah, so it is over here. Now I want to see how this river, how this artifact site, how these towns evolve over the past 40 years. So I will draw a box over here of how much area I want in time lapse. Then we will move further. Using this cell, I will be able to import the RGB combos, means which color combination I want. In this, I will be able to select the frames per second, where I have kept minimum value of 1 and maximum of 30. And this all coding structures and API documentation is already provided in the Google Earth Engine docs. We only need to find which things we require and which things we take from it and use it in our coding compilers. Then in this cell, we have to write our own formulas for the indices. So currently we have used only 3 indices over here. That is the normalized difference in vegetation index, normalized difference in water index, and modern normalized difference in water index. Then we have 2 drop downs when we select a normalized difference, where we can select any of these combinations. Then we have threshold for the elevation layers, and here we have mentioned, like, if we select vegetation index, then the first band should be near infrared and the second band value should be RED. If we select water index, then the first band should be this and second band should be this. And if we select modified water index, then the first band should be this and second should be this. Through this code, we will be able to mention the start year, end year, start month, and end month. Through this, we will be able to select some font colors. This is basically the font which we get on the top left corner, where we can see the years passing by. Then we have scale. We can scale the image length. This is the submit button on how everything works at the end. Now coming over here, after applying all this, we get this as a result, which I already showed you in the presentation, where we'll be able to select the RGB combo. So basically, this RGB combo is applied on the normal difference index for better visualization. Through indices, we get the quantitative analysis of a particular location. But to enhance the visual quality, we apply the RGB. Then here we will be able to select frames per second. Suppose I select 2 frames per second. Then I already selected the F mask property that removes the cloud, shadow, snow. Then we will be selecting start year somewhat around 1995. Let this be as it is, start month 5 and month 10. We will be selecting the normalized difference in vegetation index, where the first band is near infrared and the second band is red. And then we will hit the create time lapse button and it will start computing. So here we will be able to see the NDVI difference of that Nathan Carey area over here from 1995 to 2024 using the Landsat 9 image collection, and we saw like we got this output in under 20 seconds. And here we have used the Landsat 9 collection. Yeah, this is the Landsat 9 collection, image collection. Now, coming to the challenges. See, in the Google Earth engine, there won't be every region that you will get a clear pixel resolution. Like there will be certain regions where we don't get accurate images. So we will face certain pixel resolution issues. Also, if we try to find time lapse of very small region, then sometimes we won't get the clarity that we expect. Secondly, the data availability. Not every data will be available for every month or every day you select. It may be possible like for a region, we don't have the image for that particular month, but for some other month, there will be an image. So if we select the time lapse through this code structure, we need to verify whether the images will be there for this particular month or not. And also the remarks, like for the historic site time lapse that we did, we can use it for artifact and site preservation, and we can also use it for enhanced understanding of historical landscapes. Yeah, any questions?